sure you're with me right now. We are working on linear equations, so just talking about solving equations. We've been doing all the graphing and writing equations. So today we'll do this section. Tomorrow we're going to start looking at some word problems. So we have to know how to solve equations before we get into that. If it's linear, that means it's just an x to the first. So we're going to be able to get an answer here. So let's say I gave you this problem and asked you to solve that. Is Bryson here today?
Yeah, let's deal with this.
If I told you to solve this equation, what would we do? Start with distributing. So on the left, we need to distribute the 3. On the right, what would I distribute? A negative. Now what? Combine like terms. So 10 and negative 12, negative 2. Over here, 17 minus 5 would be a 12. Now we need to get x's on one side and the numbers on the other. So if I add over my x, can I go ahead and add my 2 in the same step? So 7x equals 14, divide by 7 and x is 2. Can you check these answers? Absolutely. You just plug them back into the original and see if it works. Don't get in the habit of thinking that you have to have a nice answer. We're going to have fractions. We're going to have decimals. So every answer doesn't turn out to be pretty in here. You can write it in a solution set if you want. We can't do an interval because it's not a range of values. It's just a single one. I don't really care. I would take it if you just said x equals, or if you put it in the solution set. Either one is fine for me. All right. Are we ready for another one? There's a couple different options for how to solve this. Anybody give me one? Well, if we were moving this forward, we would just add it over. So that wouldn't help. Did you have an idea?
Common denominator.
Okay.
Multiply the second one by 3.
Okay. So we have really, I guess I said 2, but really 3 possibilities. One possibility is to get a common denominator. So I have a single fraction over here. So if I did that route, I would have to take this one times 3 on top and bottom. So I would have x plus 7 over 6 plus 6x minus 24 over 6 equals negative 4. Then what would you do? Combine like terms. These now have a common denominator, so you can put them together into a single fraction. 1x and 6x would be 7x. 7 and negative 24 is negative 17. Then what would you do? Multiply by. That is another option though, when you could split it up like that. So those would cancel, so we get 7x minus 17 equals negative 24. Add the 17. 7x equals -7. Divide, and we get -1. Can anyone tell me another option for how I could have solved this? Let's just talk through some different things and see how you guys prefer. Is that what everybody would have done, just getting a common denominator? I mean, we've kind of done that before when we were dealing with those rational functions. We got common denominators and put them together. So that's a pretty logical first step. Another option, if I'm looking, what is the least common denominator between 6 and 2? Well, the 2, but the common denominator, like if you were going to put them together, you'd have to turn them both into 6's, right? So another option would be to just say, all right, maybe I don't want to deal with fraction. I know it's legal to multiply both sides of the equation by the same thing. What if I took both sides times 6? What would happen? So if I distribute my 6 to the first fraction, what happens with the 6 on top and bottom? It cancels and just leaves me with x plus 7. Okay, the second fraction. What's 6 divided by 2? So that leaves me with 3 times the 2x minus 8 equals -24. So this option is basically similar. We use the 6, it was just multiplying by it to get rid of it. And if you work that out, you have x plus 7 plus 6x minus 24 equals -24. Add over the 17 plus you. And we get the same answer. Okay, so that works just fine as well. The third option is probably everyone's least favorite. It's just splitting up all these fractions because there's only one thing on the bottom. So we could write that as x over 6 or 1/6x plus 7 over 6 plus 2x over 2 would be x minus 8 over 2 would be 4 equals -4. And then we can solve that equation. So lots of different options here. Now I'm not showing you 3 different ways to try to confuse you. I'm trying to show you what options we have so we can kind of pick what makes the most sense. Do you guys still like just getting a common denominator like we've done in the past and dealing with it?
The second one was probably the easiest, but more complicated problem is going to be relatively simple. Whereas when you have lots of, when the bottom has multiple numbers, it can be really complicated to say.
So, looks like we're kind of split on either getting a common denominator or getting rid of it. We like one of those two options. Everybody agrees. So I don't care how you do it, they will all give you the same answer. And I'll try to work through them a couple of different ways if we need to, if I do something that doesn't make sense. So let's try another one with those fractions. So if I were going to get a common denominator, what would I turn my denominators into? 12. If you want to get rid of the fraction, what do I take everything times? 12. It's the same thing. So we either keep it and make one big fraction, or we can just multiply by the 12 and get rid of the fractions. What do you guys want me to do? Somebody gets to make a decision. Keep the fractions or get rid of them? Keep them? Okay. So the first one currently has a 4 on the denominator, so I'm going to multiply it by 3 on top and bottom to turn it into a 12. So that would give me 3x minus 6 over 12. Second one currently has 3 on the bottom, so to get a 12 I have to take it times 4 on top and bottom. So that's the 4x plus 4 over 12. So we're getting that common denominator like we've done in the past. Now the denominators are the same, so we add the fraction. When you do that, the bottom doesn't change. So 3x plus 4x is 7x. Negative 6 plus 4 is negative 2. What would you do at this point? Mm-hmm. So if we multiply by 12 on each side, 7x minus 2 equals 24. Add my 2 and divide. I typically want fractions, not decimals. I want a fraction in lowest terms, but I don't want you to round a decimal. So I want the exact answer. Is that one okay? Let's try that. Nasty looking one. Where would I begin here? Yeah, we have to distribute. Now, these brackets, it's just like another set of parentheses. So let's just start on the inside. So inside here, what am I distributing? A negative 1. So we have a negative 5. Negative 1 times negative 9 would be plus 9. Negative 1 times 2x is negative 2x. On the right, you can distribute the 2 to get 6x minus 2. All right. I'm going to go ahead and combine these like terms. So negative 5 plus 9 is 4. So now we distribute the negative. So far, so good? What happens if I am trying to move this 6x over? They cancel out, and I'm left with negative 12 equals negative 2. No solution. So if we solve our equation and we get an answer, that is called a conditional. All of the other equations we've solved so far were conditionals. They have an answer. This one, if it is no solution, we call that a contradiction. Okay, this one is impossible. There is no x value that makes it true. It's a contradiction because negative 12 does not equal negative 2. There's a third option. If I had solved this and I had negative 2 equals negative 2, that's a true statement, right? In that case, what would your answer be?
Negative infinity or infinity.
Yeah, it's all real numbers. There's infinite solutions there. Any value of x would make it true, so lots of ways you could write that. So if I ask you to classify your equations, these are the terms we use. So if you just have one solution, that's called a conditional. What that means with linear equations, if you graph them, the lines meet in one point. If there is no solution, that's a contradiction. What that means in terms of the graph is those lines were parallel. They never cross. And if there's infinite solutions, we call that an identity, and that means they were the same line. If you were thinking about a graph. You probably want to jot some of this down. So at least conditional is one solution, contradiction is no solution, identity is infinite solutions. At least know those terms. Sometimes I might ask you to. So if we solve the first one, distribute the negative 2. Combine like terms. You might catch it here, otherwise if you subtract over, you're left with negative 8 equals negative 8. So what does that mean? So So your solution is all real numbers, and which type of equation is it? Identity. So, on a test or quiz, if I asked you, usually what our directions would say would be to solve each equation, identify any identities or contradictions. So I would expect you to tell me the all real numbers because that is the solution, and then it is an identity. B, if we add over the 4 and divide, we get x equals 3. So we got a solution, so it is a condition. All right, C, if we distribute, you have -3 equals 7, so that is no solution, contradiction. Any questions about those? Okay. Let's say I gave you this problem. Find the zeros of f of x equals 0.06x plus 0.09 times 15 minus x minus 0.07 times 15. We have a lot of decimals here. Did the decimals change how we solve anything? No. Grab your calculator if you need to. We can roll with that. It's not a big deal. But we do need to figure out, what does it mean if it says to find the zeros?
Where is the x-intercept?
Yes, zeros are the same thing as x-intercepts. How do we find x-intercepts? We put 0 in for the y. What's the y in this equation? F of x. So all I'm asking is, when does this equation equal 0? Okay. So now we need to start distributing. 0.09 times 15, 1.35 minus 0.09x minus combine like terms. Positive 0.06 and negative 0.09 will be negative 0.03. 1.35 minus 1.05. Negative 0.3. Okay, add one of those positive 0.3. Add one of those to the other side, so I'll add over my 0.03x. And divide. What do you get? Okay, so if I ask you to find the zeros, you're just setting your equation equal to 0 and solving it. Decimals don't change our strategy. We work through it the same way. Do we need more problems like any of these? Do we need another zeros example? No? You guys feel like you know what you're doing? So, there is a section 1.5 Math Excel. If you would rather take your quiz now instead of advisory, you're welcome to start that.